Guys, welcome to another short video on the following topics in chemistry. Atoms, elements, compounds, part 2.2, atomic structure of the periodic table as per syllabi 0620 chemistry. Here's the first learning outcome we'll go through today. Describe the structure of an atom and as a central nucleus containing neutrons and protons surrounded by electron shells. And the second core learning outcome from this syllabus: state the relative charges, relative masses of a proton, neutron, and an electron. Here we go. We're going to pose some questions. Here's the first question. You may answer it. What is an atom? You might have some sort of understanding of that from previous work, or you got no idea, or from reading, or from hearsay. Try it in your own words. Try and describe what an atom is. What is an atom made up of? If you do know what an atom is, you may know some terminology and vocab relating to what an atom is made up of, or the present day theory that we have today in the science and technology of this world. And the third question, if you've got all those, can you describe what an atom looks like using diagrams and label parts of the atoms? Obviously, we don't know what an atom looks like because we haven't got the science and technology to view. So this is all theory, or the best theory we have in science to try and describe the wonderful world around us. Next slide. Here's some knowledge and understanding that I want you to go through. Here we go. Atomic structure. The smallest part of an element can exist on its own and is called an atom. Atoms can only be seen by using powerful electron microscopes, and there's three types of particles that we in the scientific community call these type of things inside an atom. One is called a proton, second is a neutron, and third is an electron. The diagram that comes next will show us their relative locations. In the nucleus here, you can see in the nucleus, I'm just going to draw up here, nucleus. That's the central part of the atom. We have the bulk of the atom, 99.99% of the mass, in protons and neutrons. Surrounding the protons and neutrons by forces that we'll explain later are the electrons and their relative shells here. Also, this table, got to know this knowledge and understanding. For a proton, the mass, we call it an AMU. I'm just underlining it there. So a proton isn't really mass 1 or 1 gram, 1 kilogram. It's a specific unit for these subatomic particles. And it's about here 10 to the minus 27 per gram. I can't comprehend what mass that actually is, but we've got reasonably sophisticated technology that tells us we're fairly accurate. It's close to that mass number. 1 times 10 to the minus 27 of a gram, a billionth of a gram. Its charge is positive and it's found in the nucleus. Another particle we need to know is called the neutron. Its mass is 1, according to AMU. It has no charge, so it's neutral, and it's also found in the nucleus. The third subatomic particle here is the electron, and its approximate mass, depending which textbook you look at, is 1/2000th of the neutron or proton, or 1/1860th. And most people in textbooks like to say it's negligible. Okay, negligible. Means it's got no mass. It's in the shells here surrounding the nucleus. Now that we've got all the knowledge and understanding, let's see if we can master this with a few questions to test your understanding. Here's the first question of the quick 3. As per usual, stop, pause, see if you can answer it yourself from your memory or any information you've got. Give yourself a minute or two. The question says, draw the structure of an atom, labeling all the essential parts. So have a quick go at that. Pause the video and write something down on your computer or on a piece of paper that you may have beside you. Question 2. Give the charges and mass of each subatomic particles contained inside an atom. Can you remember those? Write them down. Question 3. Given an atom, sodium, atomic mass here, written in this format, 23. Draw the structure showing the location, the number of each type of subatomic particle. Okay, let's go to the answers. Hopefully you had an attempt to do that, because that's part of your learning, essential part of your learning, that you go through that process of thinking and writing. Here's the answers. I hope you got these right. These are just suggested answers, not necessarily what you've got, but it gives you some idea. So if you're drawing something like that, that's fantastic. Nucleus here, protons and neutrons, electrons here. We could say number 1 here and number 2 for the number of electrons in each of the shells. Question 2 here, the suggested answer. Okay, give the charges and mass each atomic particles. So we've got here, we've got the neutron, mass 1 AMU, and its charge is neutral or 0. We've got the proton, mass 1 here, and its charge is positive. And then we've got the electron, mass is 1/200, or respectively saying no mass, if you want to say that. And its charge is negative. Here we go to the third question. Okay, given an atom of sodium, now we're using the knowledge that we've got, and we're using the periodic table in a more detailed way, but you'll have to learn the periodic table's first 20 elements, pretty well much rote known, but that'll come in the next video. Here we go. So show the location number of each type of subatomic particle. We've got written down the atomic number is 11, atomic mass is 23. This is from the periodic table. Electrons 11, protons 11, neutrons 12. We'll go into a little bit more detail of how you work out those numbers in the next video following this. Here we go. So you can see sodium. Here it is. We've got in the first shell, we've got 1 electron. Second shell, we've got 8 electrons here. So we've got 1 here. And then we've got 8 electrons here. And in the outer shell, you've got 2 electrons here, my bad. 8 electrons in the second shell, and then 1 electron in the third shell. So that's like 2, 8, 1 if you're looking at the electron number order. Inside here, you've got the number of protons. So you'll have 11 protons, and then we've got 12 neutrons, and around we've got 11 electrons floating around here. Well done if you got all those answers correct. Good job. You're on your way to learning the work to a good standard, especially in the course section of the course.